All right, I'm presuming you all can hear me / see my screen again? Excellent. So you all went through and defined some terms in your own words with your new best friend and looked at some kind of pry snippets, and we're going to talk about this in a little more detail. On here, I'm going to take some notes as we go along. These notes I'll post in your Slack channel when I'm done so you have them. But the first thing we're going to talk about today are methods. And just like move my windows around. I haven't done the Zoom class in like 2 weeks. And I don't know how anything, one, I don't remember how anything works. Two, Zoom, like it has this propensity, and if you've used Zoom for a little bit, anytime you do something with Zoom, it'll just rearrange everything in whatever direction it wants. And you're just like, where did I put it? Who knows? No one knows. No one knows why it works like that. It's why technology is the worst and also the best. But a method is a group related instructions that achieves some purpose. Is this text large enough? If anyone would like me to make this bigger, I can. You just simply say so. Cool. All right. So down here in my terminal, is my terminal big enough? These two are independent, so I can make one bigger. If there are no objections, I'll continue. Cool. I want to start a pry session here by typing in pry. And pry, if you are not familiar with it, is a gem similar to IRB, but it has some extra stuff, which we'll get into later. And so when we type this in our pry session, we do hello world, and we do .upcase. Like that, we see right below, we have that equals and the greater than symbol, and then hello world all in caps, right? And we have that in the quotes. What is happening here, how we would describe this in English words, is that we're calling the upcase method. The job of the upcase method is to create a string, the version of the string with all capital letters. So whatever we are calling the upcase method on, in this case, it is a string hello world, it is going to give it back to us in all capital letters, right? And so that upcase is an example of a method. And the idea is that this method is a group of related instructions that achieves a purpose. The purpose of the upcase method is to take whatever string it is and give it back to us on all uppercase letters. And the idea is that we have this. But when we think about it, like what if we didn't have upcase? What would we do? Right? We'd have to do it like I use the term by hand. I also use the term artisanally, like the mayonnaise shops you see in Brooklyn. You get some artisanal mayonnaise. But the thing is, like, why do I want to do this by hand? Like when I think about if I had to do this on my own, well, if I have the string, I wanted all the things to be upcased and I don't have upcase, I would have to go through every single letter of the string, convert it to the uppercase version, and then return it, which is kind of annoying. So the elders of Ruby decide like, hey, we are going to make a method called upcase, and it is gonna do this work for us. And like I think that one of the most important reasons that we need methods is that methods allow us to reuse code. Instead of having to go through and check every letter in a string and make that the capital version of it, we just run upcase. We've done this invented once thing. We invented it. We decided like whoever wrote Ruby, this upcase method, did it once, and now we have the benefit for it. It's like, for example, the engineers at Ford, when they're making a new car, do they have to invent the wheel every single time? Well, actually 4 times they make a new car. Like, no, we've invented the wheel once. I would hope that at this point we have a pretty good idea of how wheels work, and we don't have to reinvent it. The engineers that work on Ruby invented how we go about upcasing every single letter in a string, and they figured that out. They've done the hard thing for us, and now we get to reap the benefits of their work. Right? Instead of having to rewrite the codes, it's already packaged in for us. And that's how we create an upcase string. We call the upcase method, right? And so the other point about methods here is that methods run on objects. Methods just don't kind of like sit somewhere on their own. They run on objects. In this example I've shown you here, the upcase method is running on hello world, and hello world is a string object. One way to think of this is that methods are like messages to an object. What we're saying for this, like, hey string, I'd like you to run the upcase version of yourself. Right. And so like the two important things here is that methods exist so we can reuse our code, and methods run on objects. Questions so far about methods? We will not move on until I get at least one good question. No, one question. One question. I don't want to put value judgments on questions. All questions are inherently good. You think you call my bluff? I will sit here as long as it takes to get a question out of you. I've got a whole big water bottle. I don't want to drink too much, then I'll have to pee. Yes. Oh, go ahead.
So are there methods that are permanent within a class? Like, for example, I know within a class, you run a method. Outside of that method, you can, if you put like a printf in of a string, it doesn't really apply that method. But if you want to apply that method, it has to be put it inside a method. So is there any method that I get, if you can understand the gist of my question? Okay.
Yeah. So the idea is that the thing is that like an example I think is like you've done puts.
Yes.
Puts you don't call out on anything, but the thing is that there's some stuff happening under the hood. Puts is getting run on like the main object, which is kind of invisible. Okay. So like they do exist, we just don't see it because it doesn't kind of work that way. Cool. All right. The next thing we want to talk about are return values. Right. And simply put, a return value is the output of a method. So what we see here is that we've run this upcase thing on hello world, and it returns us this all caps hello world. It's important to note that every method has exactly one return value, one and only one. I also do have to apologize for my typing. I recently got a split ortholinear keyboard, and it's been like learning to type again. And it's very humbling because, especially with 30 plus people watching, because it feels like I don't know how to use a computer, and like this is my job, and it appears as if I don't know how to computer. So if I make any spelling errors or typos in code as I'm teaching, please do call me out on it because I might not notice, and these fingers are not that great. Next thing is that a return value can be any type. In particular, the return value of this upcase method is a string, but we could have methods that can return numbers, it can return arrays, it can return nil, all sorts of different things, right? And so here, when we do this thing in pry, the return value is denoted by this equal sign greater than symbol. Cool. Any questions about return values? Cool. I will not force you to answer a question because that was a pretty small little snippet. Ben?
Yeah, I was just wondering, like, if you have two possible outcomes that you want, going back to how you said there's only one possible return value, what if you don't really know what you want that return value to be, or like, what if you don't really know what it's going to be? How do you handle that?
Method's gonna return something. Like you get to decide what you want return or not. and it may be whatever it may be whatever you want it to be, right? But the method is always going to return something, and sometimes that is going to be nothing.
True.
Cool. Next up, arguments. And arguments, I would describe that and define it as input to a method. Some people use the term parameter interchangeably with them. And so what I'm going to do is that I'm going to show you this example here. Hello world, and we have the string. And what I'm going to do is that I'm going to run the method include on it, and I'm going to pass it the string hello. And what I'm saying is that, hey, the string hello world, I want you to run the include method. I want to give you this bit of extra information hello. And you see here that it returns true, right? What this means is saying like, hey, hello world is the word, do you contain this string that I'm going to pass you? Hello. And it does, so it returns true. If I were to do the opposite of this, goodbye, it's going to say like it's going to return false because within hello world, we do not have a goodbye, so it's going to return as false. Usually we pass arguments when with parentheses, so we can do this. Like that. That works the same way. Parentheses are optional, but I generally like including parentheses because it visually breaks things up for me and visually kind of sets things up so where I can look at it and it's easy for me to understand what's happening. We have methods that take more than one argument. For example, we have the gsub method, which takes 2 arguments, and what it's going to do is going to look for instances of the first thing we pass to it, world, and replace that with Turing. So we see here that hello world, it found the world, and we're going to swap that out, and we're going to put Turing in. And again, this is the same as if we were to do if we remove the parentheses. Again, I generally prefer to use parentheses as it just kind of locks in things that make sense to me. Cool. Questions so far about arguments parameters? Doug?
Are there times that you have to use parentheses versus times you don't, or it's always optional?
It's always optional. So what I will say is that at Turing, we try to teach you what I call like standard Ruby. And what standard Ruby is like the kind of style and syntax that you would use in the workplace. And most everywhere uses parentheses by default. When teaching you, I will always be sure to differentiate with you the difference between what I like to do and what you should do or have to do. I think that I have really good opinions, but I do want to delineate and let you know like what are my opinions. And when I do have an opinion, I will be sure to tell you like why I feel that I do it. I'll tell you why I decided to do it this way, as opposed to why I do not. Jacob?
Yeah, I was wondering if there was any reason, like if you had a method, like if upcase took hello world as an argument versus like as an object or a method, excuse me. If there's any like why you would potentially want something like that.
Can you kind of repeat that? Potentially want what?
Okay, so I guess if you passed, instead of having hello world be the object that you were calling a method on, but instead upcase you pass it to as an argument, like for an upcase method that took an argument instead. Is there any, I guess, difference between that, or I guess I'm not sure what
Uh,
I asked.
Yeah, usually you want to call methods on object. You have to call methods on an object, right?
Mhm.
And so upcase doesn't take an argument, so you wouldn't be using arguments with upcase. Actually, this upcase might take optional arguments, but in general, we use upcase without arguments. Cool, Ben.
Yeah, something that I always just kind of wondered about is when you pass a variable as an argument, in that state, like in that method scope, what class or data type is that argument variable? Like it's not really anything because you never like
It's a placeholder.
So it's
It's
just
a
nil or
placeholder.
something.
Yes, it doesn't. It's just a placeholder that will redefine something.
Okay, cool.
All right. Next up. Next up, we're going to be talking about variables. And the definition of a variable is a keyword that we create to hold or point to return values that we want to maintain and reuse. And so a kind of real world use of that is, let's do hello world dot downcase. Right? We know what upcase does. It makes everything uppercase. Downcase, we can presume that it's going to make anything's downcase. And we downcase it, we get hello world. And the idea is that, like, well, what if I want to use this somewhere else? What if I want to use this again? Right? Do I want to do downcase.hello world over and over and over again every single time I want to use down the lowercase hello world? Like, no, that's kind of that's super annoying. So what we can do is we set the return value of this method to a variable, and then we can just reference the variable every single time we want to use it. So we can do greeting equals hello. Oops. Hello. Let's do it for emphasis. Hello world dot downcase, like that. And what we're doing is that we're evaluating every single thing on the right hand side of this equal sign and setting it equal to whatever is on the left hand side. So now if I want to do greeting, it will contain the lowercase hello world, right? We do this in order to save ourselves time. We don't have to calculate whatever the downcase hello world is. We did it once. We're going to save it somewhere, and now we have this reference that we can save to, you know, however much in the future. And now this greeting variable contains the hello world. We can also change whatever's inside there. So we could do like, oh, hello world is so 1960s. We could do greeting equal hello everybody. And now greeting, oops, says hello everybody, and then hello world is gone. It is poof. It no longer exists. What questions do you have about variables? Ben?
Maybe more kind of technical question than getting into this, but when you reassign a variable with a different string, does its place in, like, the physical place in the memory, does that variable's place in memory change, or is it just like have a different thing that's in it?
Wherever the string is a different place, because the
Okay.
thing is that the idea is that we have different the sizes have changed, so we can't really exist in the same place. It has to go
That's
somewhere
true.
else. Cool. It is 1:31. Let's take a 5-minute Pomodoro break. Let's be back at 1:36. 1:36. All right. And we're back. So far, we've looked at some methods. We've got well, we looked at upcase, we saw include, we used gsub, downcase, and these are all methods. Oh, sorry, Olivia.
Could you just make the terminal a little bigger, please?
Yeah,
Thank you.
no problem. Cool. Yes. We built these, we used methods that are built into Ruby by the Ruby team. And, you know, that's great, but there's always going to be stuff that you have to do that the Ruby engineers like never thought that would be a thing they had to do. And so we can create our own class with its own methods. So let's go ahead and do that. And we're going to make a calculator object. So we have a calculator object, and what we're going to do, we are just going to, I'm just going to copy and paste this so you don't spend time watching me type. We have this calculator file, and we have a calculator class, and we can run this by doing Ruby calculator.rb. Trevor S. I'm still learning names. I'm trying to, as I say this, I'm looking right at you. So I'm like, that is the face that belongs to Trevor S.
Yes.
What happens if I hit enter right now?
Well, it's going to put welcome to calculator
Okay.
first. It's going to output welcome to calculator, correct?
I mean, I'm asking you.
All right.
Is that your final answer?
I believe so.
Do we have any dissenters? Kyle?
I think that because you didn't actually call or you didn't initialize anything, that it won't actually print.
Okay, so we've got, all right, so let's see a vote using the participants panel. Put yes if you think it'll print something. Hit no if you don't think it'll print anything. The votes are, this is, I can count 20. We mostly no's. Let's see. I'm gonna hit enter. And we see nothing on the screen. And so we didn't see welcome printed out on the screen because we have this class keyword here and we have this def keyword here. And what they do is that they define the class. We've defined the method, but we're not actually calling any of these. So what we need to do to make this run is that we're going to first define the class. Nope. Calculator equals calculator.new. And then I'm going to do calculator.print welcome. And you see here it says welcome to calculator. Great. So how useful is our calculator so far? If you bought this app on the App Store for your phone, would you be happy with what this did? No. Does anyone here remember the I Am Rich app that they had for the phone for a while? It cost like $1,000 and all it said, well, it does display a message on your phone that says I am rich. And like they actually made a bunch of money. And I'm just like, I wish I had thought of that. But we want to add some kind of interactivity to this. And the thing is that we do this by, we're going to create some methods that take arguments, right? And so what I'm going to do is over here, we're going to make an add method, right? And so far it doesn't do anything. We need to give this method numbers to add as an input. And so what I'm going to do is that here, I'm going to put at the end of here, num1, oops, num2. And what I want to do is I want to change this out here. And we're going to make that calculator.add. And I'm going to type in my terminal, Ruby calculator.rb. Alexa, what's going to happen when I hit enter?
I think you'll get an error. Since
What error message am I going to get?
12, you need to define the numbers that you're doing in the calculator.add method.
Cool. Let's see. Yeah, it says add wrong number of arguments given 0 expected 2. And so what I'm doing here is I'm trying to call this add method and I'm giving it 0 arguments. When we define the add method up here, we are expecting 2. That's what this given 0 expected 2 means. We're giving it 0, but it wants 2. Whenever you are expecting a certain number of arguments, you have to pass in the arguments. So let's do the thing. Let's give ourselves some arguments here, 1 and 2. Excellent. And when we run it, well, nothing happens because the add method doesn't actually do anything. We got nothing in here. So the next step is that when we provide an argument to a method, we can reference these methods using the names we have here. So what I'm going to do here is I'm going to do a puts num1, and I'm going to do a puts num2. And so these are variable names that our arguments get stored in, and they depend on the order. So 1 here is going to become, num1 is going to become 1. Let me change this to 3, just so it's a little clearer, a little more explicit. Num1 is going to become 1 because num1 is first here, and the number 1 is the first here. Num2 is going to become 3 because the 3 is the second thing in the list here, and num2 is the second thing in the list here. So when I run this code, let me make sure I save it first. I expect that I'll see on the screen 1 and then a 3. Or am I lying to you? Does anyone not agree with me? I could be lying to you. You don't know. We see we have the 1 and the 3. You can think of an argument, a variable that is created at the start of the method, which you can use anywhere inside of the method. Right. So essentially what happens is that we're calling this method the first time. It takes these arguments. Automatically, when we start using this method, these variables are created for us so that we can now use 1 and 3. Or, this could be oops, that's a W. W is not a number. That is also, there we go. Come on. Like just, whatever those numbers are. It doesn't matter. Num1 will always do the first argument, which is 1, 2, 3, 4, 1, 2, 3, 4. And num2 will always take the second one, which in this case is going to be 987, 897, 897. And to prove that, we see that as so. Questions about arguments so far? Yeah, go ahead.
So I noticed that in the when you define add num1 comma space num2,
yeah.
But when you fill it out the argument, you don't have any space in there. Does that ever kind of come into play, or does it? Okay.
I put the space here because it's like it just visually, it's just easier to read. I think you can put a space here too. Well, oops, no, that is the wrong button. Okay. And that still works exactly the same way.
So like if I ever decide to add like a string in there, a string add to another string, and then I put a space in there, does that come into effect at all?
No, it doesn't. It's whatever's in the parentheses. To be honest, I never really realized it till you said this now. Like for here, there's always a space, but down here, like when I'm calling method, I never put a space in there.
Yeah,
I don't know why I do that, but I just do, and that's what mostly that's what everyone else does, and we just don't talk about it.
Okay.
Yeah, I don't. It's just a habit I picked up from just looking at a lot of code, and everyone I've worked with has done it this way. And there, as we've seen, there is no literal difference. but this is generally kind of like the style. We talk a lot. So at Turing, what I use this term, like we try to teach you idiomatic code, and it's like the idioms and how we like. It's very. I think that there's a lot of analogs between programming and just human language. When you are a part of a community, you pick up their terms, you start using the words of the language, you get a kind of bit of like a bit assimilated into like whatever community you're in. Like when we think about when you were kids, how many things did you all get into because that's what your friend group was into, for no other reason for than that was they're into. That's kind of like this very similar thing, is that not even think about it when I define arguments and methods, I'll put a space there, but I just don't do it when I'm actually using the method. I just don't, for no good reason.
So that works with method, but within a string, the space does matter. Right?
If it's inside the quotes.
It's an array. Okay, gotcha.
Right. If it's outside the quotes, it doesn't really matter.
Okay.
Yep. Cool. All right. So now we actually got to do math right now, right? That's got to be a thing that we have to do. And so we want to do return. We want this method to output or return the sum, right? And how does Ruby know what value to return? So a return value is either defined explicitly using the return keyword, or the last line of code run if no return keyword was used. So to kind of give you an example of what this might look like is that let's modify this to kind of like actually do some work for us. And so what we can do here is that we can do a sum. We're setting this to a variable. Sum equals num1 plus num2, and then we want to return the sum. This is how we would do it using the explicit return, which is what we said here. We're defining it explicitly using the return keyword. And this is what's called the explicit return, because we were explicitly saying, hey, return this. The other way, Regina, you were muted.
Yeah. So in this case, you're taking two arguments. I don't know if this is beyond like what you're wanting to go past, but let's say there are like multiple numbers, and you don't know how many numbers there will be. Is there a way of doing that?
You can take yes, there is.
Sorry. So basically in your definition there,
we'd have to structure that differently.
You don't know how many arguments there are going to be, but when you call it, you're able to put in however many.
Yes, there's a way to do that. Yeah, we're not going to go into that right now, but put that question in the parking lot thread in your Code Up channel, and I will, after class is over, I'll put a link to how you can do that. But there is that is a way to do that. Yep.
Okay, sounds good.
Cool. So yeah, this is the explicit return, and the implicit return would be this. Oh my goodness. There we go. This here is the implicit return. The idea is that this is the last line of code that's run. Whatever this gives us is going to be the return value. So go back to 1 and 3 numbers I can handle in my head. If I were to run this now, what would I see on the screen? Jake.
You're gonna go back to seeing nothing because you don't have
Nothing.
anything.
Why nothing? Yeah.
You took out the
That's
puts.
exactly right. So the idea here is that we don't see anything. Well, actually, let me hit enter and we can prove that. And we see nothing on the screen, right? We've done everything. We've defined our class and our method. We called it. We returned a value, but we don't see anything because we never told Ruby to print out to the screen. It is very like this is going. You're probably going to make a mistake like this somewhere a point in the next 6 weeks. Returning and printing are two different things. If we want to see the return value, we need to save it and print it. So what I would do is I would do answer equals that, and then a puts answer. I'm going to save that. And yes, 1 + 3 is 4. You ever have that moment of panic when you look at the 4 and you're like, no, 1 + 3 doesn't equal 4? And they're like, no, 1 + 3 does equal 4. Who here's actually done like real math on paper, like in the past year? Who did? Remember, like, I don't know, like some of you may be old enough. Remember in school when you had to learn your times table and stuff? Because you're not going to carry a calculator with you everywhere you go. And now we have our mobile phones. Prove them wrong. Katie?
Yeah, I just had a quick question. Could you also just do puts calculator.add 1 3 instead of saving storing that to a variable?
Yep. Mm-hmm, okay. You can. And I'll demonstrate right now. Still 4. 1 + 3 still 4. Yep. Yep, that is a step we can fix. Regina?
Would you ever put the puts inside the definition? Or would you not want to do that?
I would not put the puts in there. The reason why is that we're going to get into the reason why many times in the future, but the short story is that the reason why we use methods is that we want to reuse our code like over and over again, right? And so to have something print out to the screen is not very reusable. But we could think of like if we were working on some kind of code, we might need to add 2 numbers together like later on. And this is kind of a very contrived example because we're just adding 2 things together. But let's just assume that this, instead of adding 2 things together here, we're doing some really complex math, right? And so we might need to reuse it somewhere else. We want to have this method we might need to do complex math somewhere else rather than having it just print out to the screen. Yeah.
So go back to the other person's question for you. But puts calculator.add. I noticed that when you try to put anything, you created a new variable for it. Is it good practice to create a new variable for it every time, or would it be okay if I just do like puts calculator.add 1 and 3? You know?
Yeah, it depends on the situation. In general, I would. It's a complicated question because like this is your first day of Turing, and for the first day of Turing, do whatever it takes that it makes sense in your head. If you want to save it to the variable first, so it's very clear what's happening, let's do that. Moving on into the future, I would avoid using as many local variables as I could. So I would prefer at the end of 6 weeks, you get here, but right now, if you want to set to a little sum local variable first and use that, that's cool too. The idea is that we want to get you used to and comfortable using every single little piece so that in the future you can come to the decisions where you don't use certain pieces for whatever reason you decide not to use them, be it more stylistically appropriate, be more efficient, et cetera, et cetera.
Okay, thank you.
Yep. Cool.
I just wanted to make sure real quick that num1 plus num2 without return is implicit, right? That's where you get the implicit return. Cool.
Mm-hmm. if I were, and to kind of do it again, to be explicit, I would do, if I can spell, this is explicit. And again, to show you, it's still 4. In general, I would say in Ruby, it is better to be explicit than implicit, except for return values. With return values, I generally will do the implicit return. It's one of those weird lines. I always advocate for being explicit in your code because I feel that Ruby is the Ruby computing language was written to be as human friendly as possible so that people that have no experience with programming can look at it and be able like, okay, I don't know exactly what's going on, but I kind of have an idea of what's supposed to do. So it's supposed to be very communicative and expressive by design. So I prefer to be as expressive as I can in my code. And I feel that using an implicit return is perfectly fine. An example of being expressive in that regard. Cool. All right, where was I in my things? All right. So we have some time. What we're gonna do is let's take a break, and when we come back from the break, we'll work on some stuff with you and a new best friend. But let's be back at 2:05. Let's take a little bit of a longer break. Let's be back at 2:05. Cool. So we do this to show that we can call methods from within other methods. So what we've done here is create this print sum method, which takes 2 arguments. And what we do here is that we pass in the 1 and 3. It says, okay, so we are going to call the add method, send it to 1 and the 3. And it's going to add them together. And then we're going to print this method out. The sum of the first number and the second number is sum. And I think this illustrates a little better why we want to separate the printing from the actual adding. So give me a second here. And the idea here is that what if, I think a good way to think about this is like when we think about internationalization. Right now, this is in English, and we want to, let's say if we want def print some French. Right, we could do sum equals add first number, second number, and puts first number, second number, whatever, be in the different language. Right, we are now having different methods, and the idea is the difference between these 2 methods is the language we're printed out in, but we are still leveraging the addition here. And so this is how we would kind of abstract things out. Questions so far? Cool. So let me resize this a little bit. This brings us back to this this concept I want to talk about called abstraction. Oops. And the idea is that we use methods and we build methods that operate at higher levels of abstraction than other methods. Abstraction is a practice where higher level methods rely on lower level methods to take care of the details. And so what we're doing here is that we've created this method, print the sum, that will just print out the things. And what it does is it takes advantage of this other method created to do the actual math for us. The contrived example we're using here is just adding two numbers, but we can see how this can be extrapolated out to something more complicated. For example, let's say you want to take the standard deviation of a set of numbers, right? Do we have to do that math to calculate the standard deviation like every single time we use it? No, let's just have one method and then we can reuse that. We see abstraction all around us from day to day. The example I use for abstraction is that of the car. Has anyone here never driven a car? Cool. When you get into a car, regardless of what kind of car it is, how do you make it go? How do you make the car accelerate? Anyone can just unmute and say the word. Or words. How do you make cars go?
Press the gas pedal.
Which pedal's the gas pedal?
The one on the right.
Yeah, right. And the brake?
The one on the left.
Right. Do you know what happens inside the car when you press on the gas pedal? Other than the fact that it goes.
Not as well as any of us should.
Right. You know it goes. Like I'm not an expert on the fundamentals of internal combustion engines. Nowadays with like the electric cars, I'm not an electrical engineer that can explain current and generators, but we know we step on the right side, it goes. And so this example is like the methods are an example of this. The upcase method we used. Do we know exactly what it's doing to go through every single letter in a string and convert that to an uppercase thing? Like, no, I don't know. I presume that's probably iterating through each one. That's not, that's what I presume is happening. Doesn't necessarily mean it's happening. There could be something else happening. For example, like, when you have the calculator on your phone, you do 1 + 1. Do we really know what's happening that makes it add? Like, there's a lot happening from when we push the thing on our phone screen, the number 1, the plus button, and the 1 again, the equals. Like, there's a lot of stuff happening in order to make it display 2 for us. Do we know what exactly is happening? No, we just trust that it's going to give us the right answer. When I buy a hot dog, because hot dogs are delicious, do I want to know what happens inside the hot dog factory? The answer is nobody wants to know what happens inside the hot dog factory. We just know that we have delicious hot dogs that come out. And this is the same example. Like, do I really need to know? Everything is abstracted to a certain point. And the idea is that we want to deal with the kind of problems that matter. You do not have to deal with electrical impulses inside the computer that will add 1 + 1 or num1 to num2. We just know that we've created this interface, this method for us, that we can just send it 2 numbers and it adds it and we are good to go. And the idea is that we want to kind of create these lower level methods that we can then reuse in the future. So we don't have to go on and reinvent that wheel every single time we want to do something. And so that's this kind of like this big picture abstraction. Other questions that we might have about what we talked about here today? Olivia?
In our groups, we were doing an exercise.
Yeah.
And we were wondering why when you have return, we messed around with it a little bit. Then we added a second return, but it only gave us the first return still. Yep.
So the return does something what I use the term break for. It's like when it hits that return, it's like, oh, I have this return. This return means give me back whatever you're returning and then stop. It doesn't go any further. I kind of liken it to like when you lose your keys and you found your keys, do you keep looking for your keys?
No.
No, like you stop, you found your keys. And this is the same thing. This is how I return. Like, why would I continue to execute code in this if I've already returned? A method only returns one thing. If I've returned the thing I'm supposed to return, it is a waste of time to do everything else. It's always the pet peeve of mine is people use saying, it's in the last place you look. Of course it's going to be the last place you look. No one finds something and keeps looking for it. That makes no sense. Like, we return it. When we returned it, we're done. We don't need to run any further code.
Okay.
So that's something to remember when you're returning things, is that the first return it hits, that's it. You'll run nothing after that. Cool. All right. So that was a bunch of stuff. Let us take a longer break. Let's see you back at 2:45, and at 2:45, we are going to kick off your first project.